Hi, my name is Joel Geraci, and I'm the Acrobat Technical Evangelist. On this episode of IT Matters, the focus is on application security. This presentation is the third in a series that covers enterprise administration of the Acrobat X family of products. Most users have reason to care about security, but in the enterprise, security concerns are heightened by the value of the hardware, software, and most importantly, intellectual property. Administrators need to configure and maintain software clients across the organization, and workflow architects need to create secure end-to-end workflows. This presentation describes configuration details for the Acrobat X family of products, including enhanced security, scripting controls, and other security-related features. My primary goal here is to encourage enterprise stakeholders to configure and deploy the Acrobat clients and manage them in a secure way. The content here is primarily aimed at administrators, but also IT managers and anyone else who is responsible for the integrity of the networked environment. Information assurance, as defined by Wikipedia, is the practice of managing risks related to the use, processing, storage, and transmission of information or data, and the systems and processes used for those purposes. Adobe Acrobat, when configured properly, and PDF files, when created properly, can play a significant role in helping provide information assurance. Where concerned about data integrity is important, you should be concerned with Acrobat's application security options, as well as its content security features, such as digital signatures, encryption, and permissions. Application security and content security are not always functionally distinct, and both are critical components of the information assurance. For example, certified documents can enable certain JavaScript operations and bypass security restrictions that are specified elsewhere. This presentation focuses solely on application security. I'll discuss configuring the application to enable, disable, or restrict features and PDF functionality which may pose a security risk. In all cases, configuration may occur before or after deploying Reader or Acrobat. The next presentation in this series will discuss content security. The Acrobat family of products provides several layers of protections. Each layer either reduces the potential attack surface area that an attacker may exploit, or makes it more difficult for such an attack to be successful. These protections can be grouped into several broad categories. OS-level always-on protections. These are Windows-only features because they are OS-specific. Application default settings. These are not simply the settings that Acrobat and Reader ship with. The default settings can be configured prior to deployment and even locked so that end users cannot change them. And finally, user-specific restrictions. These are settings that individuals can set to allow certain documents from trusted sources to have more permissions than documents from unknown sources. For the past several years, all new code and features for Adobe Reader and Acrobat have been subject to our Modern Secure Product Lifecycle, or SPLC. The Adobe SPLC is similar to Microsoft's Security Development Lifecycle, SDL. The Adobe SPLC integrates standard secure software activities, such as threat modeling, automated and manual security code reviews, and fuzzing, into the standard Adobe product lifecycle we follow for all projects. These efforts have been successful at stopping common exploitation patterns and detecting memory corruption. These protections are built into the software and are always on. Please read the Defense in-Depth Security section of the Application Security for the Acrobat X Family of Products Guide for further details. You can access this document from the links associated with this presentation. PDF was originally a format used for viewing, printing, and sharing static documents. However, the PDF specification has evolved to include rich features such as interactive forms, multimedia, scripting, and other capabilities. These new capabilities present new risks. Adobe has proactively introduced new security functionality and is evolving its security model to combat these emerging threats. Many threats are common to all file formats, including websites. Content opened in many common applications may contain a malicious script or perform actions that can damage your computer or steal data. That's why we have virus protection software. To make viewing PDF files in Adobe Tools safer, Acrobat and Reader ship with the following default settings. Enhanced security was enabled after 9.3.2 and 8.2.2 and is the default with Acrobat X. JavaScript is enabled, but there are some restrictions on certain functions, and global access to JavaScript objects is not allowed. This lets you work with interactive forms and documents without worry. There are default white and black lists for application types that can be launched from an attachment: multimedia types, multimedia players, JavaScript APIs, and network protocol access. This gives you very granular control over more interactive elements of Acrobat Reader and the PDF files themselves. Flash applications and video can play without restriction in Acrobat because a very secure version of the Flash player is embedded within it. There are many other security-related settings. Refer to the preference reference in the Air-based Administrator's Information Manager, or AIM, for details. You can access the preference reference from the links associated with this presentation. To mitigate security attacks, Adobe provides a security model designed to help you protect your environment. Administrators in particular should explore the available options for tuning applications to the desired security level. Some of the security-related features that are configurable by end users and administrators include the following. Protected mode in Adobe Reader on Windows. Protected mode sandboxes processes to limit what malicious code can accomplish on an affected machine. Enhanced security and trusted locations limit cross-domain access, JavaScript injection, data injection, and silent printing. Cross-domain access can be configured in Acrobat and Reader or managed on a server via a cross-domain file. JavaScript can be entirely disabled or allowed on a per-document basis. A blacklist enables restricting particular APIs. The application ships with a default list of allowed and disallowed file types that can be launched from attachments. The list is customizable. The Trust Manager provides tools for specifying permission for all or specified URLs. Multimedia playback can be controlled on a per-document basis. Non-Flash multimedia types are now turned off by default. And finally, Adobe periodically ships new Adobe Trusted Identity Certificates for use as trusted roots for verifying digital signatures. As an administrator, you may want to lock users out of changing security settings that you determine should not be changed, such as the list of trusted hosts or the ability to turn off protected mode. Look in the Feature Lockdown section of the Preference Reference for more detailed information. Protected mode represents an exciting new advancement in attack mitigation. With protected mode enabled, all operations required by the viewer to display the PDF file to the user are run in a very restricted manner inside a confined environment, the sandbox. The effect is that even if an exploitable security vulnerability is found by an attacker, protected mode will help prevent the attacker from writing files, changing registry keys, or installing malware on the potential victim's computer. Protected mode is enabled by default, but is not locked in the on position. To lock protected mode so that end users cannot modify this setting and turn it off, use the registry panel of the customization wizard as I explain in part 2 of this series. Enhanced security is part of the new security model introduced in version 9.0. Adobe recommends that you enable enhanced security to prevent unrestricted domain access and other potentially risky behavior. Workflows and content should be designed to operate in the context of having enhanced security enabled. Enhanced security is enabled by default for version 10 and version 9.3 and 8.2 updates. Its configuration and behavior is nearly identical across platforms, when viewing a PDF within a browser or within the standalone application. Enhanced security consists of two components: a set of default restrictions and a method to define trusted locations that should not be subject to those restrictions. In other words, you can either block dangerous actions altogether, or else selectively permit them for locations and files you trust. When you enable enhanced security, your application hardens itself against risky actions by doing the following for any document not specifically trusted. It prevents cross-domain access. It forces requests for new content to adhere to a same origin policy. This means access to web pages and other resources originating from a domain other than the one your document is hosted on is prohibited. It prohibits script and data injection via an FDF, XFDF, and XDP that is not returned as a result of a post from the PDF file itself. It stops silent printing to a file or hardware printer, and prevents execution of high-privileged JavaScript. These protections are specifically targeted at protecting users against popular web attacks such as cross-site scripting, cross-site request forgeries, and others. When enabled, enhanced security may affect legacy and new PDF workflows. It is specifically designed to let you decide what content to trust and help you selectively bypass those restrictions for trusted files, folders, and hosts. These trusted domains, called privileged locations, are exempt from enhanced security rules. There are several other methods for establishing trust, and just as you tune your browser, you should tune Acrobat and Reader so that they operate at a risk level that is appropriate for your environment. Enhanced security configuration can occur via the Acrobat user interface. However, in enterprise settings, administrators will likely want to tune the preferences at the registry level. Doing so not only provides more granular control, it also provides the means to lock those preferences so that they cannot be changed via the UI. When configured for your workflows, malicious attacks such as cross-site scripting are prevented, and a rich user experience is provided in the context of a safe and trusted environment. Most or all of the security warning dialogues that appear when a PDF file is trying to access the web can be prevented by managing these settings in this dialog. This feature interacts with other features that also assign trust. When content is trusted as a result of a cross-domain policy file, for example, that content is not subject to enhanced security restrictions. If you would like to trust any sites that you already trust in Internet Explorer, make sure Automatically Trust Sites from my WinOS security zones is checked. It is checked by default. This makes managing trust much easier because you only need to keep the list in one location, either Windows Control Panel or in IE. This section of the presentation describes how to configure the Acrobat family of products to allow cross-domain access for PDF files in one domain that attempt to access data from another domain. By default, when the requested content is not from the same origin as the requesting document, Acrobat and Reader automatically attempt to load a server-based policy file from that domain to get permission for such access. Administrators and IT managers can enable or disable cross-domain access. As the Acrobat family of products became more powerful over the years, adding support for Flash, JavaScript, and web service interactions, the line between documents and applications has gradually blurred. With the addition of interactive form features, multimedia, and scripting, PDF files became more capable with each release. Like your browser, these new capabilities present new risks. On the one hand, support for JavaScript and dynamic content within a web page allows developers to add rich interactivity and behaviors to their content. On the other hand, these features can be abused by hackers. Problems arise because while security is critical, strong security is often at odds with usability. To make matters worse, different browsers implement their same origin policies slightly differently, and maintaining a reasonable level of browser compatibility results in complex code that never bodes well for security and sometimes results in a less than desirable user experience. Adobe began addressing this problem several releases ago by implementing a standardized cross-domain security model that has evolved over the years into a robust, secure solution. By providing controls for which documents can receive data from which sites, Adobe clients such as Flash and rich PDF documents in Acrobat and Reader are safe and extremely flexible. We do this through the use of cross-domain policy files. A cross-domain policy file is an XML document that grants a web client such as Adobe Flash Player or Adobe Acrobat permission to handle data across domains. When a client hosts content from a particular source domain and that content makes requests directed towards a domain other than its own, the remote domain needs a host, a cross-domain policy file that grants access to the source domain, allowing the client to continue the transaction. Acrobat and Adobe Reader behave similarly with respect to data access, and their behavior is consistent whether running in the browser or as a standalone application. However, behavior inside and outside of a browser varies because of differences in HTTP and HTTPS request handling. When Acrobat or Reader is run from inside the browser, the application behaves similarly to Flash running in the browser. Same domain requests do not require a check, and across-domain checks do. When Acrobat or Reader run outside of a browser, such as when viewing a document on a local file system or opening a PDF file as an attachment in an email, data requests from an HTTP or HTTPS server are blocked. A check is always required. The server must also have a cross-domain policy file containing a wildcard, or the local file must be in a privileged location in order to interact with the file properly. Because wildcards in a cross-domain policy file are not considered to be best practice, I'd advise the use of privileged folders when running interactive PDF files from the local file system in the standalone viewer. This may involve some end-user training, but you'll be far more secure. JavaScript support is one of Acrobat and Adobe Reader's most powerful features, and Adobe provides several controls that enable tuning application behavior so that JavaScript executes within your own desired level of security. The Acrobat JavaScript Blacklist framework was introduced in versions 9.2 and 8.17 and provides very granular control over the execution of specific JavaScript APIs. This mechanism allows selective blocking of certain APIs so that you do not have to resort to disabling JavaScript entirely. The blacklist is maintained in the Windows registry and the Macintosh OS X feature lockdown file. On Windows, there are two blacklists, one for enterprise administrators and one used by Adobe security patches and updates. The JavaScript API blacklists are in two locations on Windows. The Windows Enterprise List is the blacklist that helps enterprises roll out policies that block exploitable JavaScript APIs from executing in their environment. Populating the blacklist is the responsibility of the enterprise. Adobe patches never modified this registry location. Adobe's Update and Patch List is the Adobe blacklist and is modified by Acrobat and Adobe Reader patches whenever an API is deemed vulnerable. APIs are also removed from the blacklist whenever a fix for a vulnerability is provided by the current patch. The two blacklists interact so the most restrictive wins. So, if one blacklist blocks an API and the other does not, the API is blocked. If a blacklisted script is encountered, all other scripts in that document are blocked. The Acrobat JavaScript Blacklist framework lets the IT manager determine the level of interactivity and risk associated with using these advanced Acrobat capabilities so that you can feel secure when working with PDF files. Like email messages, PDF files can contain attachments. In fact, a PDF portfolio is a little more than a PDF cover sheet, a Flash UI, and a bunch of attachments. The Acrobat family of products allows you to open and save PDF and FDF file attachments. However, the other file types represent a potential security risk because they can contain malicious scripts, open other dangerous files, or launch applications. Certainly file types such as .exe and .bat will be recognized as threats by most users and are not allowed as attachments. But to further mitigate the risk inherent in attachments, just like with email, you need to educate the users not to open attachments unless they know what the content is and where it originated. They should also be aware of dangerous file types and how to manage those file types. Adobe applications maintain blacklists and whitelists to control the behavior of attachments and prevent attachments from opening other files and launching applications. I know that was a lot of information on application security, but I want to emphasize exactly how secure the default installation of Acrobat and Reader are while providing the flexibility for IT managers to tune the applications to their specific needs. Again, both application security and content security are important for information assurance, so be sure to also watch my show on content security. Until then, please visit the show page for links and other valuable resources. Thanks for watching. And don't forget to visit my blog at IT Matters for the latest information on Adobe Acrobat.